Hello, today we're going to talk about how to find the inverse of a function. So I'm going to give you a function. I'm going to expect you to tell me what is the inverse to that function. So let's take a look at our first example here. So if we have something like this, the f of x equals x to the fifth minus 2. And what we want to know here is what is the inverse of it? Well, our steps are pretty simple. We're going to switch the x and the y variables, and then we're going to get y by itself. That's the easiest way to algebraically find the inverse to a function. So you say, well, there's not a y right here. Well, remember, we can look at it as y if we want to. And then from there, I'm going to switch the x and y. So I've got y equals x to the fifth minus 2. So where the y was, I write x. And where the x is, I'm going to write a y. From there, get the y by itself. So I'm going to add 2 to both sides. I get x plus 2 equals y to the fifth. And then I'm going to take the fifth root of both sides. That's the opposite of raising something to the power of 5, right? The fifth root of the left side is equal to the fifth root of the right side, which is just going to be a y now. So y is by itself. This is the inverse to our original function up here. Now remember what we said in the last video. We said that if we have two functions like this, we'll call this the g of x. So the g of x equals the fifth root of x plus 2. And then we have the original function, the f of x equals the x to the fifth minus 2. If these two are inverses to one another, then the f of g of x should equal x, right? So let's test that out. What is the f of g of x equal to? So when we write that out just to test, that's all we're doing is we're testing to make sure that we did our work correctly. If I take the f function and everywhere I see an x, I'm going to replace it with a set of parentheses. And then where that parentheses is, I'm going to put the g function into it like this. Now, if I work this out, simplify it, it should simplify to x if I did everything correctly. So the fifth root and fifth, they knock each other out, and I end up with x plus 2 minus 2. And then from there, the positive 2 and the negative 2 cancel out, and I'm left with just x. So indeed, the f of g of x does equal x there, okay? So be very careful with these directions, because sometimes I might say, tell me, verify that these two functions are inverses. If I'm giving you both functions and say verify that they are inverses to one another, it means take the f of g of x or the g of f of x and show me that it equals x. That's if I give you two functions and say find the inverse, or sorry, verify the inverse. Now, if I just give you one function and say come up with the inverse, that's when you're doing the methods that we're doing today, where we switch the x and the y and solve for y, okay? Let's take a look at another example here. The f of x equals the square root of 4 minus x squared, and I'm restricting my domain this time so that it's got to be between 0 and 2. So you might be wondering, like, why are we restricting the domain on this one? This one isn't our typical parabola. But remember, the parabola isn't the only time that we have issues with the domain and trying to find the inverse. This is another example right here. So I first want you to look at this and think about it and say, what does this shape right here look like on a graph? See if you can remember, and if not, we're getting ready to look at it in Desmos. Let's go ahead and do that. Let's switch over to Desmos and see what we have here. So in Desmos, when we graph this, we get something that looks like a semicircle here. That's what it is. And let me take this horizontal line off. That's what we're looking at right now. Now, I want to ask you the question, is that right there a function? Yes or no? Yes, it is a function, right? It passes the vertical line test. But when we go to flip this thing, remember, to find its inverse graphically, we draw that line y equals x, and we're going to reflect it over the line y equals x. So what happens is this thing starts to look kind of like this, like a backwards C there if we were to find the inverse that way, and it wouldn't pass the vertical line test there. So we need to be careful when we're talking about these things. We say find the inverse, but what we're really saying is find the inverse function. So whatever the inverse is, it needs to be a function. And right now, if we reflect this over that green line there, you're going to get something that will not pass the vertical line test. So this thing needs to pass this horizontal line test. As I move it up and down, it can't intersect the graph more than once. In a way, you could look at the horizontal line test as doing the vertical line test before you reflect it. So that's not a bad way to look at it. So what we need to do is restrict this between 0 and 2. Notice anything beyond 2, it's not going to work algebraically in it. So let me go ahead and type that in. So how do you do that when you're graphing? Well, you can click on the little squiggly bracket like that and say x must be greater than 0 here. And now look at what it creates. It creates something that does pass the horizontal line test. And now we can reflect it over the line y equals x. Now looking at this, I want you to make a prediction on the inverse here. When we reflect this over y equals x, what's the inverse going to look like? All right. And we're going to go ahead and figure it out algebraically if you couldn't see it from just the graph there. So let's switch back and let's go ahead and do our steps here. We're going to switch the x and the y. So I get x equals the square root of 4 minus y squared. And we're going to we're going to square both sides. So squaring this side will get rid of the square root bracket, and I get 4 minus y squared. Squaring the left side gives me x squared right here. And now from here, we're going to keep solving for y. So I'm going to subtract 4 from both sides. I get negative 4 plus x squared is equal to negative y squared. Multiply both sides by negative 1, and I get 4 minus x squared equals y squared. And then finally, to get y by itself, I'm going to square root both sides. So square root this side, and I get y. Square root the left side, and I get the root of 4 minus x squared. And then so from here, let's see what we've got going on. Oh, wait a minute. This is the exact same function that we started with, isn't it? So in this case, what I'm getting at here is that the inverse to the original function is the function itself. Sometimes we have functions that are inverses to themselves. So you might reach this point and say, yeah, I don't quite believe you. Well, there's a couple ways we can check this. First, go back to Desmos. Now think about that reflection. That reflection is going to land on itself because it's perfectly symmetrical over y equals x. So that's your big clue there that the function is an inverse to itself. But if you don't believe me, we can work this out graphically. Not graphically, algebraically. If we call this the g of x, and this one right up here is still the f of x, well, all we got to do is see, does the f of g of x equal x? So that's what I'm going to figure out. The f of g of x, does it equal x? That's the question. So if I write out the f of x, and everywhere I see an x, I'm going to replace it with a set of parentheses. And everywhere I have that parentheses, I'm going to put the g function into it. Well, the g function, I know it's the same thing, but we're going to substitute it in for x here. So I get 4 minus x squared. And now from here, this is when I'm going to go through and simplify it and see if it equals x. So the square root bar right here and the square, they're going to cancel out. And that leaves me with 4 minus, and in parentheses here, 4 minus x squared. Okay, remember, we're still subtracting. I know these canceled out, but we are still subtracting all of 4 and all of negative x squared. And that's important because what that gives me is 4, you got to distribute that negative. That's why it's important. You end up with 4 minus 4 plus x squared, and we're square rooting the whole thing. And then from there, we're going to say, okay, 4 minus 4 is 0. So I end up with the square root of x squared, which equals x. And so indeed, the f of g of x in this case does equal x. And so we can say they're inverses to one another. Let's look at one more example here before we go. I'm going to take the f of x the f of x equals 4 over x. So once again, to find the inverse, we're going to go ahead and call the f of x y. Then we're going to switch the y and the x right here, and I get x equals 4 over y. And now I need to get y by itself. So I'm going to multiply both sides by y. And I get 4 over x. And y is by itself. Sorry, multiply both sides by y. I skipped a step in my head. And I get y times x equals 4. And then divide both sides by x. And you get 4 over x. Notice once again that this so happens to be the same function. So you say, what's going on here? Let's switch back to Desmos and see what this graph looks like. So I'm going to go ahead and just get rid of that function. And I'm going to leave that in there because that's helpful sometimes. And we get y is equal to 4 divided by x. Notice what this graph looks like. It passes that horizontal line test, so I can actually just kind of turn that off for right now. And notice if we were to reflect this over the line y equals x, it lands perfectly on top of itself, right? So graphs that are symmetrical over y equals x, when you flip them over y equals x, they land on top of each other. So that's when you're going to have an inverse that's exactly this original function, okay? So like the first example shows, not every time that we have a function, the inverse function is the exact same function. But there are times when it happens. So that's why I put those two examples in there so you could see that, okay? Our example problems that I give you for homework will have a mixture. Some will be the exact same function and some won't be. But remember, if you feel a little unsure of whether you got the answer right or wrong, take the f of g of x and you should get x there, okay? So if you have any questions, let me know. Get your practice problems in and I will see you next time. Thanks for watching.